Hello, I'm Jeff, and welcome to Getting Started with Amazon GameLift FleetIQ. Today, we're going to talk about just what is GameLift, what is this new FleetIQ feature. We're going to look at some in-depth examples for, how does FleetIQ work, what does it do, and how does it integrate with your game backend. And then I'm going to flip over and show a live demo, both through the command line interface and the web console, just showing the interactions between, your game server, your matchmaker, and GameLift, and how FleetIQ might piece into your game backend. So, first off, though, I'll talk about GameLift is part of the larger AWS GameTech organization. GameTech helps developers build faster, operate smarter, and create innovative games using Amazon Web Services. You can use this with any platform, genre, or engine, and 90% of the world's largest public game companies are using AWS. And awesome developers like Behavior, Ubisoft, Panzerdog, and Bethesda already trust GameLift for their games. Now, for anyone who might be new, I'm going to start right from the top with just a quick intro of what is GameLift. Well, it's an AWS service, helps developers deploy, operate, and scale the dedicated servers for their session-based multiplayer games. It has a bunch of features to help you make sure you're paying the lowest possible price for those servers. It's available in 15 geographic regions worldwide to make sure your players are getting a low latency experience. It comes with the same high availability and security that you'd expect from any AWS service. And one of the things we want to point out today is that it's very flexible. Its features are meant to be plug and play so that you can integrate these into your game backend the way that makes sense for you. Now, I'm going to start at the 30,000 foot view and just talking about where does GameLift fit into your game backend. In this example, we'll have game clients. These are a player on an end device, like maybe a console. In this example, your player wants to enter the matchmaking queue to start a new match. Well, the first thing you're going to do is actually talk to your own backend services. You're going to want to authenticate that player, authorize them, maybe do an entitlement check or check the player database. And so the key here is that your game clients still talk directly to your own game services. You can build those services on AWS using some of our primitives like Lambda, or maybe an out-of-the-box solution like GameSparks, however you want to do it. But after this step is where GameLift comes in. And so what you're actually looking at is GameLift APIs are meant to be called from your game services, not from your clients. So in this example, we said that your player wanted to join the matchmaking queue. Well, GameLift has an optional matchmaking system. It's a rules-based, flexible system we call FlexMatch. Its job is to find groups of players who will have fun games together based on the rules that your developers programmed via our text language. So FlexMatch will find groups of fun players, and then it passes it on to the next feature in GameLift, which we call global placement queues. The queue's job is given a set of players and their latency information. It's going to scan across all of the capacity you have worldwide and place those players on a server that will give them the lowest latency experience possible. And those pools of capacity we just call fleets in GameLift. So that's where GameLift fits into your back end. What does GameLift do for you? Well, we talked about some of the features it has to help you save money. Out of the box, something different with the cloud is your players you can dynamically scale up and down versus, hey, if you're using traditional on-prem capacity, you generally have to purchase capacity to reach your high watermark of your players, right? Your players come and go, they're going to have a peak point during the day. And when you do the math, when you're using fixed on-prem capacity, you're actually wasting half of your servers over the course of any given day. Now with the cloud, because capacity is dynamic, you can just set auto-scaling rules that we call target tracking. You set a rule that says, hey, maybe you want 10 or 15% unused, that players never wait for a server. And you just tell it to, hey, follow that line, and you can immediately see you're saving about 50% of your server usage immediately. Now, another piece that's different than if you're using traditional on-prem is how you pack your game sessions onto your game servers. So in this example, in on-prem, we'll say the orange are your actual physical hardware servers. The blue boxes are your game sessions, and generally the algorithm with on-prem is you spread across evenly. You've got that hardware anyways, you want to use them, so you spread out. But when you're using the cloud to make the most out of auto-scaling, you actually want to pack those game sessions as densely as you can. And so you see in this example, we actually could use 1/3 of the capacity we had, which again saves you money, makes auto-scaling much more effective. Now, GameLift does these things out of the box for you. I actually consider these features to be just table stakes for using the cloud at all. If you're just building your own system on the cloud, you just need to do this. The real innovation that GameLift came up with is how to leverage spot capacity for low-cost servers. And so a spot instance represents EC2's unused capacity available for up to 90% off, so quite the discount, but it does come at a trade-off. That's if EC2 needs that capacity back, it's going to issue your instance a 2-minute warning and then terminate that instance. Now you can imagine if you had players playing a game on that instance, 2 minutes generally is not enough time to wrap up that session naturally. And so, that instance might get terminated while your players are still playing. And you don't want that. You don't want to, put your player experience at risk. And so on GameLift, we were thinking, could we take advantage of some of the unique properties of session-based multiplayer games to help developers get access to spot capacity without putting their player experience at risk? And that is what we call the FleetIQ algorithm. The unique property of the game sessions are that, hey, they're short-lived. They generally only last 5 to 30 minutes, maybe 60 minutes on the outset for some rare games. And that 5 to 30 minutes allows us to create a prediction algorithm for all of the spot capacity that we're managing. That algorithm's sole job is saying, hey, if we placed a new game session on this instance right now, what is the probability that that instance might get terminated before the natural end of that game session? And we call that spot viability. If we think there's any probability at all that that instance might get terminated early, we say the instance is non-viable for game sessions and we wouldn't use it. We only place game sessions on we consider to be viable spot instances. And what this looks like is, every time you start a new game session, it's going on the low-cost viable instances. As instances that were viable go non-viable, or stop placing sessions on them, we'll drain them naturally and then cycle them out from under your group. And so under the covers, it looks like we're always rebalancing your capacity, but your players will never notice this. And we'll get into some more detailed examples later on, so don't worry about trying to get your head around that just yet. Now, GameLift has actually had this predictive algorithm for viable spot instances for over 2 years. We've gotten pretty good at it. And so I'm not just hand waving. In practice, we see only 1 in 75,000 game sessions on our viable spot instances get interrupted. And so we're pretty good, but we're not totally eliminating your risk to your player base. And so this is something for you to take into account if you want to take that 1 in 75,000. In practice, we found that to be extremely effective, as well as we have plenty of customers who are seeing even better than this. And certainly this is much lower than even the natural crash rate of a lot of game servers. So I said FleetIQ, the underlying predictive algorithm, has been used in GameLift for 2 years, so it's tried and true. So, what is the new feature? Well, for developers who can use GameLift or are using GameLift, they're very happy with this. But we found a large set of developers who maybe can't use all of the GameLift features, maybe because they already have existing on-prem capacity and they just want to mix some cloud capacity in for burst, or maybe they have already built existing systems that do a lot of what GameLift already does and they want to stick with those systems. So we wanted to figure out how we can give those developers the same access to our low-cost viable spot instances without having to adopt, all of the rest of the features of GameLift that they might not be able to. And that's what we're calling the new FleetIQ feature. It's this very separated application of low-cost viable spot instances. And I'll dig into exactly what it is now. So this is kind of the getting started. Put on your administrator's hat. You've got the command line interface and you're setting up FleetIQ for the first time. And what it looks like is you'll call the create game server group in GameLift. And what that'll do is actually create an auto-scaling group in your account. Auto-scaling group belongs to you. You can do anything with it, but GameLift will be updating it along the way. Now, your auto-scaling group will be responsible for launching your EC2 instances that'll contain your game server. Now, how you get that game server on those instances is up to you. It's very flexible. You could bake an EC2 AMI. You could use a deployment service like Code Deploy, or you could also use container management like Kubernetes with or without EKS. The whole point is that it's very flexible to plug into however you want to manage your server capacity. Now, this is the setup state. This next picture is going to go through, once you're set up, what does the API cycle look like between your game servers, your matchmaker, and GameLift? So just a little bit of a recap. Hey, you've got your game server code. It runs on an EC2 instance. This is just showing that very common for game developers is to run multiple game servers on a single EC2 instance. Of course, you can do that. And those instances are getting launched by your auto-scaling group. So far, this is just a recap. But the new thing is, well, how does your game server interact with GameLift? Well, you integrate the AWS SDK, and when these game servers start up, they're going to call register game server in the GameLift API. That makes your game saying, hey, I'm here, I'm awake, I'm healthy, and I'm available to take a new game session. Now, at some point, your matchmaker is going to want to start a new game session on a game server. It's going to call the claim game server API. That API is going to apply our viability logic, making sure we're only placing on viable spot instances, as well as it's also going to atomically claim a server so that there's no races in between your matchmaking threads. And once we have atomically claimed a server, we're going to go and update that auto-scaling group to set instance protection. This makes sure that auto-scaling won't scale down any instance that has your players on it. Now, once your game server has one more step, which is it's now claimed, but once the players have actually arrived, it's going to call GameLift again and call update game server here to just say switch itself from I'm claimed but available to I'm claimed and utilized. And this will just fix race conditions where your matchmaker might claim a server but players never show up and whatnot. So we just there's that extra closing the loop, get rid of any race conditions. Now, this is one specific flow where, hey, your matchmaker is, starting games with all the players there, which is, the very typical MOBA startup. But we also have APIs for listing. So if you want to do list and pick, or if your matchmaker does backfill, however you want to pack those game servers. This claim game server can also run our packing algorithm, or you could try and claim a specific game server. So by default, you'll get all the value that we've talked about in the slides so far, but you can also use it any way you want for how you actually pack games. It's flexible that way, even though I didn't show it in this specific diagram. Now, just a little recap, what does FleetIQ do for you? Well, I think about it as really, it's an auto-scaling group that runs in your account, takes care of instance packing when you start new sessions, and instance protection to make sure that you're not scaling down instances that have players on them. And then the real magic is the viable spot instances, making sure we're balancing across instance types and availability zones based on our predicted viability, and safely draining game servers so that your players don't notice any of this movement underneath the covers. And that's a lot of hand waving. There's a lot of logic that goes behind Spot. So I'm actually going to walk through a couple concrete examples to show you what's actually happening here. We'll start with what we call instance balancing. And this shows you really how FleetIQ is working in conjunction with your auto-scaling group. So in this example, we'll say you gave us 2 different options of instance types and 3 different availability zones that we're allowed to spread across. And you're going to see this later as well. To take the most advantage of Spot instances, you're going to want to give us the largest range of instance type and availability zones that you possibly can. So it gives us the maximum chance to get you the lowest price servers, and also the maximum chance to make sure that you have a viable spot capacity at all. And we'll show what happens if maybe that's not the case. So 2 instance types, 3 availability zones. We're going to spread that capacity out as evenly as we can as the auto-scaling group launches these instances. And eventually what's going to happen is our viability algorithm is going to decide, for whatever reason, the entire 1C availability zone should not be used for spot instances. We call these a non-viable zone. Well, we're going to update your auto-scaling group to remove that. And that'll cause your capacity to be rebalanced into 1A and 1B. And you can see these lines went up as expected. Now, eventually, one of your instance types might also go unviable. And you say, hey, there's C5 larges are just not viable for game sessions in spot. That's okay. You still have C4 larges. We're going to pack all your capacity into that. You can see these lines keep going up. Everything's working as expected. And eventually this scenario can happen, which I mentioned earlier. We'd say, actually, none of the instance types that you gave us are viable for spot. And when this happens, you have 2 options. One, and it's configurable on the group. One of your options is to say, I only ever want to be on spot. And if there's no viable spot instances, don't launch replacements. You would only do this if you had a higher level placement mechanism that could fall back to other zones, or maybe other capacity that you have sitting around. But that's a little less likely. The much more likely scenario that you'll want is, hey, I always want to try and launch on viable spot, but if there's no viable spot, just launch me on normal on-demand instances. I'll pay full price, but my game will still be up. I'll have the capacity I expect. My players won't have any impact. And so we rebalance you across on-demand. And eventually what's going to happen is spot instances will become viable again, and we'll just balance you off the on-demand back onto the lower cost spot instances. And so this whole dance is what we call balancing. So balancing instance types and balancing availability zones by manipulating your auto-scaling group. Now, as you saw that dance, you're probably thinking, well, if my players are playing games on those instances, like how are you making sure to not interrupt them as you're doing all of this balancing? And so that's what we call instance draining. And we'll go through a similar example for that scenario. So very similarly, you've given us 2 instance types, C4 large, C5 large. Your auto-scaling group says it should have 4 instances. You have exactly 4 instances. They're all utilized with game sessions. And so everything's great at this point. Your game's going the way that you want. Now, eventually, we're going to say C5 large instances are no longer viable for spot. We should try to stop using them. What we'll do is update the auto-scaling group to mark these existing non-viable instances as standby. And what standby means is these instances are still running, your players are still playing the game, they're unaware, but the auto-scaling group will see that, hey, it's actually underscaled. It wants 4 instances, you only have 2, and so it'll start launching replacements. But it will take a few minutes for replacement instances to get launched. So in the meantime, what's going to happen is, hey, one of these standby instances, maybe the game ends naturally, it's now available. You think it's available, it's now able to be terminated by us because it's non-viable, but we won't. We actually don't terminate this instance at this point in time, even though we think it's non-viable. And the reason why is that would actually put you below your target size of 4. And hey, when you're only talking about 4 instances and terminating 1, that's not a big deal. But if you imagine, hey, your game at full scale and maybe 50% of your capacity just went non-viable at the exact same time, you want to make sure you keep all of that capacity so that you're not risking your players having to wait for new game servers. So we're going to keep the standby instance around. As new game sessions start, we're always going to try to prefer placing them on these good non-viable instances. But if you run out, then hey, we'll come by and place it on one of these standby instances. And in practice, because these things just went non-viable and our prediction algorithm is trying to look ahead, more than an hour, this is generally totally okay, and you're not taking a huge increased risk on your players. Now, eventually, the auto-scaling group will catch up. You'll have your replacement instances launched. You now have more than enough capacity for your target, which was 4. And now we can go ahead and start removing these standby instances, but only once their game sessions have naturally concluded. So I just showed, that one went away. Eventually, this game server, the game will end naturally, and then we can go ahead and terminate that. So that's the dance around draining to make sure that, hey, as we're doing all of this balancing, we're never actually impacting any players. And even, in the edge conditions where there's these wild swings in viability, we'll make sure that you're never underscaled during these transition points. So some best practices, if you do go and integrate FleetIQ, we talked about this earlier. The key is you really want to give us the largest selection you possibly can of instance types and availability zones. This gives you the biggest chance to get the maximum savings of spot, while also making sure that, hey, there actually is a viable spot for you to take advantage of, and you don't end up, going over to on-demand and paying full price when you don't need to. So, think about C4, C5s, M4s, M5s, often interchangeable. People often will use, large, X large, 2XL, and they'll just say, if I can run one game server on a large, then I could run 2 on a 2XL, and I could run 4 on a 4XL, and make sure they're just packing their games appropriately to the size of the instance. Now, we didn't quite mention this, but GameLift is modifying that auto-scaling group in your account. It also creates that auto-scaling group in your account. And so in order to do that, you have to create an IAM role that you pass to GameLift that gives GameLift permission to create an auto-scaling group and then modify it in your account. We'll take a look at this in the live demo. You can just copy and paste it right out of our documentation, but we do provide a managed policy to make sure you get it all right. I would just go ahead and use that. And then finally, again, it's the nature of session-based games, that 5 to 30 minute game session time, that really makes this all work. If you have an MMO game where the servers may stay up for days or weeks, I would not use FleetIQ for that, or I'd be very careful. The predictive algorithm will not work for those game sessions that last so long. It's all about session-based games, 5 to 30 minutes, maybe 60 minutes. And so we can always be swapping out your capacity. Just keep that in mind. Now, there was a lot of slides. There was a lot of talking. What I'm going to do is jump over now and just show you a live demo of what this looks like, setting it up in both the command line and the web interface. Let's go get my PowerShell here. Let's get my web browser. So the first thing actually is I'll come over to the IAM management console. This is identity and access management. It's where you set up your permissions and your roles. I'm not going to start from scratch because we're going to assume you have some familiarity with AWS here, but I am going to show you what the 2 roles that you're going to want to create when using FleetIQ. The first is what we talked about. You need to create a role that will allow GameLift to create auto-scaling groups and then modify them in your account. I'll go ahead and take a look at what this looks like. I named it the role to hand GameLift. It's quite the policy document, but you see, hey, it's only allowed to modify auto-scaling groups that GameLift actually created, so it's not free reign. And you can copy paste this right out of our documentation, but we also do just provide a managed policy to make that as easy as possible. I would just use that. Now, the second role you're going to want to think about is your EC2 instance themselves are going to want an instance role that will allow them to call out to other AWS services as you need, including in our demo calling GameLift itself. And so just think about the 2 different roles that you're going to want, one that gives GameLift permission and one that gives your game servers permission to call other AWS services. So that's the first set of setup. You've gotten your permissions correct. The next piece of setup that I'm not going to show is just how do you get your game server onto an instance. For the sake of my demo, I just baked an AMI. So this is just normal EC2. I put it in the launch template, so you can just see my launch templates in this account. And my AMI here, that just has my game server baked into it. And what happens is when the instance starts up, it'll run my game server startup script, and the game server will start up and register with GameLift. So no magic there. You can do this however you want. I did it with an AMI. So great. Looking at the CLI, now that we've gotten set up, like let's actually show creating some of these groups. First thing I'll do is just show you, hey, I actually already have one game server group. I even called it the existing group, just so we can see what two of these things look like. And I'm going to go ahead and create a new group, and I'm going to copy and paste this command so you don't have to watch me type out a whole account number and everything. We'll look at, hey, what does that command look like? So we're just using the AWS CLI. The API is create game server group. You can give it a name it whatever you want. We called this new one demo. This is the role ARN that I talked about and we looked at just a little while ago. It's game server group. This is what gives GameLift permission to your auto scaling group. Basic, group size, the launch template that specified the Omni that had my game server in it. And these instance definitions is where you're telling us what instance types we're allowed to use. For the demo, just like the slides, I'm just going to say C4 large and C5 large. But again, you want to give us as many options as you can. So you can go ahead and describe this group. As you see, it starts in this new. It's going to go through a provisioning cycle. It's already active, which means it's created the auto scaling group. It's already launched some instances. And what we're waiting for is those those EC2 instances to start up so that my game servers, right? Notice the difference. This is describing the game server group. Now I'm going to try and list the game servers for my demo game server group. It should be empty. Yeah, because it takes about 2 minutes for those instances to start up and my game servers to register. So in the meantime, what I'm going to do is go to the GameLift console and see all of the GameLift features are here, but all we're concerned about for FleetIQ is game server groups. I'll refresh here. You can see I had my existing group that has already existed for a little while. The demo group is the one we just created. I'll go ahead and click on that. And the key here is what it links you to is the auto scaling group in your account. And it just shows some of the flexibility here of, you own this auto scaling group. You can do anything you want with it. You can, let's say, enable detailed metrics. You could set scheduled actions, lifecycle. You can set whatever sophisticated scaling policies you want. Again, the point of this feature is because this runs in your account, you have full flexibility to customize this and integrate it any way you want into your game backend. We'll look at, hey, it's already launched that instance. It's great. I'll go back to the CLI and see if it's been just long enough that we have some game servers up and registered yet. Just a little bit longer. So while we're waiting, the other thing that we'll point out later is you get CloudWatch metrics for these groups. So you can see everything that's happening. In the auto scaling console, you can see all of the actions that we've taken. So in this activity history, you can see when instances launched, when they go away. This is where you'd also see the rebalancing actions that we would take. So, hey, if we put instances in standby, if we moved them around, you'd start seeing a bunch of action here in the activity log. Now, perfect. So now our game servers have come up. They've registered with GameLift. And so now what we're going to do is to register with GameLift. Right, so now this is where your your matchmaking system comes into play. So now you've got a game server group. It has game servers actually registered and saying, I'm available for a new game. And your matchmaker is going to want to claim one of those game servers. Here we're going to use all the defaults, which means use our packing algorithm to claim. We'll go ahead and call claim. Now this is just the sake of a demo. We're pretending to be your matchmaker. You'd never do this from the command line, but we're showing what happens. So you claim a game server. We go find what we think is the best one per instance packing. And you'll see what happened is that game server's claim status moved to claim. This is how we atomically claim these things to make sure there's no race conditions. But the game server itself is still available because it needs to close that loop to say, yes, players actually did show up. And so what I'll use is now we're pretending to be the game server. and we're going to call the update game server API. And we're going to set our utilization status to utilized. And the important thing here is to get the game server ID correct for the one that was just claimed. We'll go ahead, copy and paste this. And you can see now we're both claimed and utilized. And now your game server, we're not showing this, but it'll also, as part of its health check, it should also be heart beating every once in a while, maybe every 60 seconds. Hey, I'm still healthy, I'm still here, and I'm still utilized. We'll go ahead and list the game servers again and just show you, hey, there's one available, there's one claimed and utilized, exactly what you'd expect. And at some point, your game session is going to end naturally. And your game server is probably going to want to take some cleanup tasks before wanting to register itself as available again. So once your game is naturally done, your game server will actually call deregister. And again, we'll go get the game server ID correct. And once it deregisters, what we found is very common for game servers. It wants to perform a bunch of cleanup actions. So you can see we're down to one. It wants to perform a bunch of cleanup actions like uploading logs and maybe restarting its process to clean its memory. And so you deregister, your game server will deregister itself. It'll go through all of its cleanup steps. It can optionally restart the entire process. And when it comes back up and it's ready to be given another game, it'll call register again, which will add itself back to the list of instances that are available. Now, we talked about, other ways is claim uses our packing algorithm, but if you wanted to do your own packing, you can just list the available game servers and do the claiming yourself of claiming specific game servers, which will use your packing logic. You could also list if you just want to do backfill or lobby-based searching. Instead of what I've been using this as a demo is what I consider typical matchmaking in a MOBA example. So I'm going to show you one last thing over in the console, which is our CloudWatch metrics that we're emitting. So you come over to just the CloudWatch console. I'm going to click all the way through because it can be a little hard to find. You want to make sure you click on the metrics. I actually have several GameLift examples going on, which is why you see all of these other metrics. But really, all we care about for FleetIQ is these game server group metrics. And we'll show, hey, available game servers, utilized game servers for the demo group, which is the one we just created. I'm going to go ahead and make sure that we're doing 1 minute metrics. Yeah, make sure you get that right. And you can see here's the metrics for what we just showed in these last couple of minutes. You can see available game servers go all the way up and then to 2 and then come down when we claim 1. Utilized game servers go up. We have a handful of metrics to help you understand what's going on with your game server. And these metrics here were just because I also ran this demo, practiced this demo a few hours ago, and so that's why there's these remainder metrics here. I used the same game for the game server. So that's the metrics. I think the last thing I'll show is just a very, very simple Python game server, just to show you like the bare minimum amount of code here. And you see this is again a server that'll just start up and register itself. It has a couple of convenience methods to just grab its instance ID from the metadata because it needs that when it registers. It's going to get its own server IP because it's going to register that metadata with GameLift so that when your matchmaker calls claim, GameLift can pass that connection information onto your matchmaker, which can pass it on to your players if you so want to use it that way. You can see the register API is just a simple API call. And I'm just going to register and I'm going to pass some connection metadata. And listen socket is just the message passing part of the game server. And here's the main method, right? All that happens, we gather some of that metadata, like instance ID and IP address. We register ourselves. We start a thread, which is waiting for players to show up. And all we're saying is, hey, if we're going to keep heart beating that we're healthy and available, And if players ever show up and we were available, we're going to flip our status to utilized. We're going to update that we're utilized. And then as part of our health check, we will continue heartbeating that, hey, we're utilized and healthy. And when this ends, it'll go ahead and deregister itself. So, of course, this is just like the absolute bare minimum possible to show, what this game loop can look like in this demo. Of course, in a real game server, you don't want players to just show up. When they do, you want to authenticate them and make sure they can actually be in that game session. But this is just the bare minimum to show you how this works. So that's the live demo. We go back to the slides. We say, what do we see? Well, FleetIQ is a new feature that provides access to these low-cost, viable spot instances using the same prediction algorithm that we've been using in the rest of GameLift for over 2 years. So it's battle-hardened. But now it's broken out so that developers who don't want to use the rest of GameLift or can't use the rest of GameLift, maybe because they have existing on-prem capacity they want to mix in, or they want to use a different or existing server management solution like Kubernetes or something you've already built on your own, we're now providing those same low-cost, viable spot instances for developers who fall into that bucket. It works by creating an auto-scaling group in your account. And so everything it does is transparent. You can see it and you can integrate it and customize it any way that you like. So just wanted to say thank you. If you like this demo, I'd say, hey, go check out our blog. We have other demos and videos that you can take a look at. We have other customer case studies that you can take a look at, how some other customers are seeing success with GameLift and what they think of it. And give us a try. We hang out on the forums. If you have any questions, you can reach out to us there. So say thank you very much. Have a great day.